Good morning, everybody. Welcome to class this morning. Thank you for joining me if you are here with me live. If you're watching this recorded later on, thanks for watching. So this week, we're getting started with Module 2, which Module 2 is called How the Internet Works. And so essentially, we're going to talk about how the Internet works, which makes a lot of sense. When you look at it from that perspective, you know, what we're examining for the majority of the class, right, are things that utilize the internet in some form or fashion. You know, when we get into web development around Module 5, 6, and on into things like databases and things of that nature, these are things that need the internet to be able to exist. And when we're talking about things like software development and things of that nature, in 2021, we oftentimes see things like SaaS, software as a service companies, or just regular software distribution being done over the internet, right? Like it's an internet age. Everything is done online, right? Especially over the last 18 months, we've seen things that we would normally do in a different manner start to move toward an online sphere, right? Even this class that we're in right now is online. And so having an understanding of how the internet works helps us to understand more about what we would need to do to be able to do these things that we want to do in this realm. I won't go too deep into that because that's your discussion topic for the week, and I want you all to get into those concepts yourself. But before we do all that, before we get into all that stuff, let me just give you a couple of announcements here. One is that your assignments for Module 1 were due yesterday. I'll be grading those at some point this week. I looked through and saw that the majority of you submitted everything on time, which is great. Really appreciate that. If you have any questions about any of that or need to know any information, please contact me. Send me an email, send me a Teams message, whatever you'd like to do as far as that goes. Remember that when I grade, my policy is that I will grade things from within 7 days of the due date, which was yesterday. I like to do that to keep everybody on an even playing field, which I think I mentioned to you all before. You know, just making sure that, nobody's like figuring things out and then sending out information to everybody else. That sort of thing keeps us on a level playing field for integrity purposes. So with that being said, I think that's the only announcement that we have for this week. I guess another one would be thank you for putting up with me last week for the delayed live stream date. Of course, that was because of the Labor Day holiday here. So, the college was closed. And kind of bigger than that, I just wanted you all to have a day to rest, even though we haven't really been going that long. I think, having a mental health day every now and then is something that is important. So there's that. With that being said, I guess we can get back into our content for this module. We're talking about the internet and how the internet works. And so in talking about these things, I think it's pretty critical for us to start with some definitions and then move into some other stuff that is specific more toward your lab for this module, right? So let's start out by kind of defining some of the components of what makes up the internet, and then we can get into some other stuff. Good morning to you too, Casey. Thank you for joining me. So the first thing that we kind of need to dive in on would be, some of these hardware components. So I think the first thing that we want to look at here is our server. So when we start to consider the internet, I think, we have to start considering the server from the jump, right? The server is the big point of kind of what makes up the backbone of the internet. We look at various types of servers that do various types of things. We'll talk about DNS later on today. DNS is hosted on a server. Websites and software and data files are all hosted on servers. And so essentially what we're looking at when we're looking at a server is a combination of hardware and software that allows us to have this sort of home base for a website or any other type of application. This is kind of the point where, when we are making that request to get a website, our website comes back to us from its home on the server, or a copy of that website, which we'll talk more about in a little bit, comes back to us from its home on the server. And there are three primary types of servers that we'll look at relatively quickly. We have our desktop server, our rack server, which might be one that you're more familiar with from like the networking classes and stuff, and then a blade server. But I just kind of want to run through the three of these really quickly. But really, any of these, right, when we look at these, they're all essentially the same thing. They're just in a little different architecture. And when we think about a server, right, or we think about one of the modern buzzwords for servers, cloud, right? You might have heard the term cloud. Cloud is just some servers where data is stored somewhere. Right, so one of the things that we want to think about is that these are essentially just, good morning to you too, Kansas. Thank you for joining me. One of the things that we want to think about as we're thinking about these servers is that they're essentially just a computer, somebody else's computer that you request data from, that you send information to and request data from. So whenever we hear cloud or server, it's a computer. A big, glorified fancy computer. Right? It's just hooked to us via the internet. So let's have a look at these three different basic types of servers, our desktop, our rack, and our blade. We'll start out with our desktop server here. We have an example photo of a desktop server here. And when you look at this, you'll notice that it doesn't look a whole lot different from your standard desktop PC, right? It's a little bit bigger. The size here is so it can store more hard drives, more storage expansion options here. But when you look at it, it looks really similar to your standard desktop PC. Just a bit more robust. Another name for this is a tower server. And I like to talk about this one first just because it really does a good job at showing you that servers are really just souped up fancy computers, right? They're just somebody else's computer that has more storage, more processing power than your standard regular old desktop or laptop computer that you'd use somewhere. And visually, I think this does a good job showing that because as you can see here, doesn't look a whole lot different from, one of the servers or one of the towers that you'd see, like in 3200, our computer lab here. So there, this does a good job of a visual representation of that. However, one of the servers that you'd see more often would be this rack style server. So you take several of these and you mount them in a rack. Now, like one of the things to think about here is space and space concerns. You can see like these desktop servers, they're not designed to kind of stack on top of one another. If we had to have multiple of them, they'd take up a lot of room, right? But with these rack servers, these are designed to go into this rack. And as you progress, especially through your networking classes, you'll see more examples of these. Or you might know of a server rack, or you've seen rack-mounted things before. But with our rack servers, we can take several of these, we can stack them on top of one another in a single rack. And those are the kind of servers that we see in these big data centers and things like that, right? We see a bunch of racks filled with either rack-mounted servers or blade servers, depending on the applications. Blade servers coming up next. One of the things that makes utilizing rack servers difficult is that since they're stacked one on top of another, cooling becomes hard, right? And you'll see that cooling is a big factor in data centers, right? A lot of data centers do what they call hot aisle, cold aisle containment, where they'll kind of put a partition around their servers so that they can blow cold air in one side and have the warm air taken out the other side. It's a really interesting, really, especially if you're in it, right? Like if you're offered a data center tour, like I know a lot of you are online students and you don't have the opportunity to be in a certain place at a certain time. But if you're offered an online tour, or if you're offered a data center tour through one of your networking classes, I encourage you to try to go on it so you could see these things, see these servers in action and see how they work with them. And you can see these things like hot aisle, cold aisle containment, how they air condition these servers, and all of like the VESDA systems and things like that to help like make sure fire suppression happens. And it's really incredible. And like the technology that they've put into these things to keep these servers safe, because a lot of these data center facilities are either mission critical or business critical, meaning that they need to they should be up 24 hours a day, 7 days a week, if at all possible. So seeing the process that they put into place so that this can happen is really, really cool. So if you get that opportunity, I encourage you to take it. But we're able to kind of take that desktop server that you saw, fit it into a more streamlined form factor here, and put a bunch of them in one place instead of having them take up more room. Finally, we're going to talk about the blade server, which is just a little bit different, right? So in terms of design, blade servers are similar to rack servers, but they cost a good deal more. One of the things to kind of look at here is when we look at our rack server, we can see these different like hot swappable bays here in the front where we can kind of open them up, take out hard drives, install new hard drives, so on and so forth. Whereas in our blade server, a lot of that is contained in a blade. So you just pull out the whole blade, do what you need to do, put the whole blade back in, which in terms of efficiency, it's way more efficient to run maintenance and things on these types of blade servers. And you can get more in one place because they offer a thinner architecture, but they are very expensive, which is why you'll see more often rack servers instead of blade servers used for a lot of applications, just because cost is an issue, right? And so on these servers, right, like, to us, it's nice to know about these servers, right? You'll see them more and you'll work with them more in like networking classes. But for our purposes, for programming and web development and things like that, the bigger deal is the server software. So let's talk a little bit about server software. We see server software in what we call stacks. Right? Let me write that up here. We see server software in what we call stacks. And we can have different types of stacks as server software. And when we see a server stack, we typically see something like we have in this graphic here in the lower right-hand corner. We call them stacks because they're different layers of software that all do different things. One of the most common is the type of stack that you see here in the lower right-hand corner. which this is a lamp stack, LAMP. Conversely, we also have WAMP stacks, WAMP, and MAMP stacks, MAMP. And they're all essentially the same thing with just one slight difference. Right? Because we'll go ahead and write our lamp stack up here with them. You can see that we have these three different stacks here. The only real difference is that first letter. Typically, when we're considering these stacks, we have the operating system, which is at the base of that stack. When we're talking about an operating system, we're talking about the core software that allows all of the other hardware components and all of the other software on a device to work together. So we need an operating system to kind of make everything work. And so we have a WAMP, MAMP, or LAMP stack. In our LAMP stack here, we can see that it's Linux. That L is for Linux. And so Linux is the operating system here. And saying that it's the operating system and having the understanding of what operating systems are, and that this one is Linux, we can probably infer what our W and our M stand for. Our W is for Windows, and our M is for Mac, right? So we can have a server that's based in Linux, Windows, or Mac operating systems. Any of these are valid in this particular stack. We can use these to just kind of control the hardware and the software and get everything communicating back and forth. From there, we have the different pieces of software that actually make it a functioning server. For our A, which is the same A for all three of these, it's Apache. Apache is essentially our server software. It's the software that helps determine our protocols. So it's, doing the TCP/IP for the server. It's doing the HTTPS protocols, HTTP or HTTPS protocols. It's the layer that's kind of helping to send our information. And then the final two that we have here are some sort of database and some sort of programming language interpreter, right? So the M here is for MySQL, which is the most widely used database in the world. If you continue in the programming and web development track, we have an entire class on MySQL and how to use MySQL to generate queries and get information and all that kind of stuff. Just because SQL at the very least, but more specifically MySQL, is the most widely used database in the world. We actually do a little bit of MySQL in this course toward the end of the semester, so you can get ready for that. And then finally, P, we can see in our graphic here, it's PHP or Perl or Python, right? P could be any one of those, right? It's typically when we see a LAMP, MAMP, or WAMP stack, which we also call an XAMP stack, just because it's like that first character can be a variable. Typically, when we see these in general, it's going to be PHP, right? PHP in one of these stacks is one of the most widely used, primarily still because of WordPress, right? Like 90% of the internet's WordPress sites. WordPress is based on a PHP foundation. But we're starting to see more and more site architectures being built with other programming language interpreters. Now, one of the things that you might notice that I've not said anything about here in terms of our server stack is HTML, CSS, or JavaScript. And JavaScript's kind of a questionable one, right? And you'll see why that is in just a second. But that's because HTML, CSS, and JavaScript are not interpreted. by the servers. What JavaScript is in some special cases. But the type of JavaScript that we write for website scripting is not. So we're not looking at the server to interpret that. What we're looking for there is the server actually sends us a copy of any HTML, CSS, or JavaScript files that it has on it, sends them back to our browser, and our browser is what takes the HTML, CSS, all that stuff, and makes it something that we can see in a nice, pretty interface. Right, so we call this front end versus back end. So when we look at our server stack, these are back end softwares. And specifically, when we're looking at things like MySQL and PHP or Perl or Python, these are back-end languages. These are things that need to be interpreted by our server and get converted into something that our browser can understand. So it takes this information from PHP, from Perl, from Python, and converts it into HTML and CSS before it sends it to our browser. That way, when our browser gets it, it knows exactly what to do with it. Same thing with MySQL. It goes ahead and pulls the data out of the database at the server level and sends it something your browser can understand, or it gets something from your browser and interprets it into something that the server can understand and puts in the database. So these are back-end languages. When we're looking at HTML and CSS, we call those front-end. And you can almost kind of think of it like, you know, if you've ever worked at a restaurant before, or you've seen kind of how a restaurant works on television, you can almost kind of think of it as like front of house and back of house. You know, your back of house is where all the cooking goes on. It's where all the raw materials are turned into finished dishes. And then in the front of house, that's where you have your servers. They take those dishes and they deliver them to you. Right? So that's kind of what's going on here, right? Like on the back end, that server's processing all that data and turning it into information and getting it ready for you. And then your front end takes that and delivers it to you in a manner that you can read and you can interact with and all that kind of fun stuff. So we can kind of think of it that way, which is pretty cool. So our most typical stack is going to be a LAMP stack. However, it's not the only stack. Right? So here we have a comparison of one stack versus another stack. Right? On the left-hand side here, we see our LAMP stack that we were talking about on the previous screen. On the right stack here, we see what we call a Mern stack. Or no, this is a mean stack, rather. A mean stack. M-E-A-N. And we can see how we derive that. M, MongoDB, E, Express, A, Angular, N, Node. There is such a thing called a Mern stack that replaces Angular with something called React, which is my preferred framework, but that's neither here nor there. And so they're a little bit different here. They're a little bit jumbled out of order just so we could make a nice acronym with them. Like, you're not seeing the direct comparison across from one another. Like, MongoDB is not the operating system for a mean stack. Technically, the operating system is Node.js in this case. And it's kind of a combination of... It's actually more like Apache in this case. Node.js. But we have this other stack for other applications. And it's when we get into these other applications that are more new, more modern, that's where we get into those things where I was talking about a few minutes ago where JavaScript can be a special case. Because in this mean stack, JavaScript is actually a back-end language. There's some extra frameworks here in Express.js, Angular.js, and Node.js, where you can write some special JavaScript that gets interpreted by the server before it gets sent to you. So for our purposes right now, this is not a big deal. This doesn't really matter. Like, we could talk about the differences between like our database in MongoDB and MySQL, but it doesn't really matter a whole lot at this point. At this point, what we're just trying to say is that there are different server architectures that can do different things for different applications. So having an understanding of what you need for your particular project becomes incredibly important. So now that we have this kind of understanding of our hardware and our software, and that we can look at this software and see that it's broken down into these parts where we have this back-end language and we have a front-end language, we can start to break down the actual process that's going on when you make a request. And this is our interaction between clients and servers. And so when we're talking about a client, we're talking about a user's device. And a client can be anything that, you can access the internet on. Desktop, laptop, Chromebook, mobile phone, tablet, whatever you've got. If it has the ability to access the internet and request a website, then it is considered a client. And so the client makes a request to the server, right? The server has the information that the client wants. When you say, I want to go to, let's say, when you say, I want to go to www.espn.com, you're making a request. You're saying, I want to see what's on espn.com. I want to get the sports scores or whatever. And so one of the things to kind of keep in mind is with that little demonstration there, you saw how quickly I got that reply back with all of those files. I said, hey, server that has espn.com, let me see the files for espn.com. And it sends you that response back. Okay, here you go. Here are those files. And then your browser renders that HTML, that CSS, that JavaScript, so you can see that information. Right, and so when we consider this, one of the things that I like to kind of make this related to is this idea of a store. Right? Let's say for a moment that we have this store. This store exists somewhere in town. And this store has what you need, whatever it is. And so one of the ways that I was relating this to my seated class, my seated version of this class, is let's say you want a refrigerator, right? So you live over here somewhere. This is you. And you got the store over there. And so, refrigerator, it's pretty big. You're probably going to need some help getting it, right? So you make a request to that store. You say, hey, store, you've got the fridges. I want a fridge. Here's some money. Give me a fridge. They say, okay. They load that fridge up in a truck. And they bring it back to you. So we have this simple kind of two-way information pathway here. But as you might have guessed, it's not quite as simple as it seems. All right, there's a lot of other little factors here that make this a bit more complicated. Right, like the first thing is, well, we have to be able to get that request to the store, and the store has to be able to get that fridge back to you, right? So let's say in this example, there is no internet, right? Since it's an internetless world. So you actually have to physically go to the store. And the store has to bring you your fridge in the truck. Now with that, you have a series of, whenever you're driving, you have some rules of the road that you have to obey. And whenever our information is getting sent back and forth on the internet, there are some rules that it needs to obey, and there are some protocols that it needs to adhere to. And so that's what TCP/IP is for. This is TCP/IP stands for Transmission Control Protocol and Internet Protocol. And these are our communication protocols that define how data should travel across the internet. So when you get in your car and you travel somewhere, you say, well, I have to obey the rules of the road. I have to stop at the stoplight. I have to stop at stop signs. I have to yield right away to whomever, right? In whatever situation. If I'm in a turning lane, I have to turn. Our TCP/IP dictates the protocols, kind of dictates the rules that define how our data should travel across the internet. And this TCP/IP was introduced with ARPANET. So this kind of takes what we were learning in this module and relates it to that previous module when we talked about history, right? The idea of TCP/IP came from ARPANET. And so we see from those early stages that TCP/IP continue through to this day, right? So that's back in the, back in the late 60s, early 70s, we were developing that ARPANET stuff. And those same protocols define how data travels across the internet today. Now, let's say, for a minute, you're going to Walmart. Let's just consider for a minute that you're going to go to Walmart. How do you refer to the fact that you're going to Walmart, right? This gets us back in, we're still in that store analogy here. How do you refer to the fact that you're going to Walmart? Do you say, I'm going to 705 East Dixon Boulevard? Or do you say, I'm going to Walmart? It's the same deal with our websites, right? Like Walmart has a physical address. It's 705 East Dixon Boulevard. But nobody says that. They just say, I'm going to go to Walmart. We had that example earlier. Where we pulled up the browser there and we went to ESPN.com. Well, ESPN.com has an address. It's 54.239.152.92. Right? And just like you'd have a hard time remembering 705 East Dixon Boulevard, and if you were referring to that to anybody and saying, oh, I'm going to 705 East Dixon Boulevard, they wouldn't know what you mean. You'd have to say, I'm going to Walmart. Just like you'd say, if I'm going to 54.239.152.92, that's the IP address, the IPv4 address for ESPN.com. But you can't remember that. You don't know what that is. Nobody that is, unless they're in the know, right? Nobody would know what that is. You'd have to tell them, I'm going to ESPN.com. So how do we get that ESPN.com to relate to that address? Right? How do we know where to send that traffic when we're on that address? Well, that's based on something called DNS, domain name servers. And this is essentially an address book for our websites. Right? So essentially what happens is when I make that request, my browser is taking and turning that domain name, that ESPN.com, and it's going out and saying, okay, which server has this domain name? Which server, what is the address to ESPN.com? And so it sends that information to a domain name server through the ISP to try to find out where this is located so we can get the files from it and send them back. So essentially what's happening here is that we have this domain name server, and it essentially has a big table in it. And this table on this domain name server allows it to relate that domain name to the proper IP address. So then you don't have to remember that IP address. You just have to remember the domain name, and that makes life a whole lot easier, right? So that's another step in that process. You know, for our purposes of our analogy of, you know, going to the store and going back or whatever, we can kind of think of it like maybe a GPS system or maybe an information center, a little information booth, right? Because, like, you know, if you use your GPS on your phone, you can type in somewhere like Walmart, and it gives you directions to the address. You know, you don't necessarily have to know the address to be able to go there, which is beneficial. Now, we also need to talk about HTTP for a minute. This is our Hypertext Transfer Protocol. And this is sort of that language. This is a language thing. So, like, whenever you type in your address into the address bar, you know, you type it in http://www. So essentially what that means is HTTP, Hypertext Transfer Protocol. So we're using the Hypertext Transfer Protocol as the basis for this language. It's hypertext, right? So we're going to be communicating via hypertext, which is HTML, the Hypertext Markup Language. This is the stuff that the World Wide Web Consortium was developing at CERN, right? To tie it back to the last module as well. In order to communicate in HTML, that hypertext markup language, we have to use our HTTP, our Hypertext Transfer Protocol. So this is the application that allows this language for clients and servers to speak back and forth to one another. You know, to be able to receive that data in HTML and our browser to be able to understand the HTML. Which is pretty cool. So with all that being said, I think it's time to get down to the nitty-gritty. Right? Get down to, like, the big important things that you'll need to know to complete your lab assignment for this module. because I ask you to kind of draw all this out and explain it, which is you open up that browser, you do like I did a few minutes ago, you type in that website, whether it's, ESPN.com or clevelandcc.edu or whatever it is. So you enter that URL. What happens next? Right? What happens after you enter that URL? And we have essentially a 5-step process here. First, a request is sent to the domain name system server or the domain name server. Those are kind of interchangeable. Then the domain name system server or the domain name server translates that domain name to an IP address. So now it's figured out the address where these files are located. So then your browser uses that IP address to go and request those files. So it's requesting the files from the right server. The server sends the response with the required files, which are those front-end language files, that HTML, that CSS, that JavaScript, and then your browser loads those received files so you can see that website. So the first thing is that we send a request to the DNS, right? So along this HTTP or HTTPS protocol, right? The S just stands for secure, right? One of the ways that I like to describe that is like if I'm standing on one side of the room and my friend's standing on the other side of the room, and I yell across to them, that's kind of like communicating on the standard HTTP protocol, right? Anybody who might be listening in around me could hear that and could pick up on that data and could potentially use it for other purposes. With that secure protocol, essentially what I have is I have a verified line of communication. My friend being who they claim they are, right? Just like that server being what it claims to be. And I have it could be like talking on walkie-talkies. Right, so you're getting less of that potential interference. But we have a domain name like google.com or like espn.com or like clevelandcc.edu. And this is all a part of the Uniform Resource Locator or URL. So we enter that URL and we make that request. And the request is sent to the ISP. The ISP then forwards that to the DNS server, the domain name system server, or just the domain name server. Either one's acceptable. So your browser sends that request to this server. So it's made one request of one server. And so then that server takes that URL, takes that domain name, and converts it into an IP address. And then that IP address is sent back to you, which is part of what makes this impressive, right? Like we have these requests and responses, right? We send one request and one response and get one response from a server. So when we are sending our DNS server a request, it gives us a response, and that allows us to send another request to the IP address that we get. And like when I pulled up ESPN.com a few minutes ago, or when you pull up any website, right, you see how just blazing fast that is. Right? Like within a second or fractions of a second, you get that response with all the files that you need back. And knowing all these steps makes it even more incredible that all this stuff happens in that amount of time. So once you get that IP address, your browser sends another request to the server with that IP address that you got from that DNS server. Pretty cool. Right? So you get that one request, that one response. Now we're going to do another request and get another response. Right? So it sends that request to that server. That server says, okay, yeah, I've got the files that you need. Here's the HTML. Here's the CSS. Here's the JavaScript that you need. Here you go. I'm going to send that back to you now. And finally, you get those files back. Right? And when you get those files back, they are processed in a particular way by your browser. So the HTML files understood first, right? Your browser takes that HTML file and says, okay, this is the HTML file. Because typically that HTML file is going to also tell it what other files that it needs. Whether it needs CSS files, whether it needs JavaScript files, whatever it needs, that HTML file, that hypertext markup language, that file that we get over Hypertext Transfer Protocol, that communication medium, remember, is going to be the main source of information for our browser. So this is the first file that gets parsed. And that file is going to tell it, I need this CSS file. I need this JavaScript file. I need a bunch of these files. Right? Because it's not just one most of the time. So the HTML file gets parsed. The parsing of that HTML file creates something called the DOM, the document object model. And we'll just kind of mention it for right now. When we get to our HTML modules a little later on, we'll talk more in depth about what the DOM is. But it's essentially this tree structure that is generated from it. So everything has like parents and children and all that kind of stuff. So when you're applying styling to this HTML, when you're using JavaScript on this HTML, you're able to target specific elements within the DOM. So we have this. So from that, we're able to bring in all the linked CSS, and then we have something visual that's on the page. And then typically after the HTML and CSS are all loaded, it parses and applies the JavaScript. So this gets us that full paint, if you will, of the website on the page. So think about that. Add that into your worldview here, and of all the things that you're considering about what's going on when we say, oh, what's at www.google.com or what's at www.espn.com, right? We're sending this. So we're first saying, okay, espn.com. Right, I'm going to go to espn.com. Right, I've entered in this URL. What's about to happen is my browser is about to say, okay, DNS server, who has espn.com? Who has that as their domain? Give me back the IP address for that. Okay, so then the domain server says, okay, this site has the IP address, the one that we mentioned earlier. ESPN.com is tied to the IP address 54.239.152.92. Okay? So then it sends that back to the browser, and then the browser says, okay, website at 54.239.152.92. I want your HTML file. Okay, so then it says, well, okay, here's my HTML file. And then as it's parsing that HTML file, it says, okay, I need these CSS files. I need these JavaScript files. Can you send me those? Here you go. And then it parses all of them and makes them into something you can see. So all of that happens that quickly. Right? In that amount of time. And something that makes this even more impressive is that I can show you how many files it's actually sending back. Right? We have one HTML file, right? One site is one HTML file. But in doing so, if I select inspect here, and then in my inspect panel here, well, first thing we can see here in my elements panel, I can see all the HTML here. But if we look at my sources panel here, all this stuff is CSS and JavaScript and images that this one particular file needs to work. Like here's a JavaScript file. Here's a JavaScript file. Here's a bunch of CSS assets. And we can see here that there's a ton of them. There's an absolute ton of files here. Logos, pictures. And all of these files are being requested from this server. Or really from multiple servers once we get into things like CDNs and stuff like that. Not a big deal for where we're at right now. Right, that's a little more of an advanced concept that we'll talk about later on. But when we see that, we really see just how impressive it is that we're getting these websites within, seconds or fractions of a second. Because of all the files that have to get transferred, because of all of this request protocol and everything that's going on. It really is impressive. And so as we get ready to wrap up here, that gets us on step 5, which is that our browser loads all the received files in that parse order that we were mentioning. And then we're able to see that website and use that website. And whenever we click a link on that website, that whole process starts again, right? Because essentially what you're doing when you're clicking a link is you're making a request for that page now. And you want to get that page and all the files that are associated with that page. Now, thanks to something called a cache, we don't download all of the files every single time, right? If a website uses the same files over and over again, it puts them in our local cache, CACHE. And that prevents us from having to download all those same files over and over and over again, which is highly beneficial. Saves us bandwidth, saves us time. But that is, in a nutshell, sort of the simplified process of what happens when you request a website. And that basically kind of boils down just into its syrup, if you will, the most reduced form of how the internet works. Obviously there's more complicated things at play here, right? If we broke it all out into all the little nuance and all that kind of stuff, we could just talk about that for the entire, semester. But one, we're not going to do that. We have better things to talk about. And two, where we're at this point, we don't need to know what that stuff. And we, almost don't care about that stuff. All the little nuance, right? A lot of the other stuff is super important to us, like the stacks, the software stacks, and the communication protocols. What's going on and how are these files, what order are these files parsed in? That kind of stuff becomes super important to us because it impacts directly what we do or what environments we can use or how we're supposed to code, right? If you're a professional developer and your boss says, we need this application put on a lamp stack versus we need this application put on a Mern stack, well, that's two completely different things. And you'd have to develop different software, write different code, according to which environment you'd have to put it on. The locations of your different files in your HTML and how you call different files impacts how it's all parsed and is impacted by the parse order. So it's all pretty critical. Exactly how it's critical, I'll let you explain to me through your discussion assignment and your lab this week. We're basically at our wrapping up point now, so we'll go ahead and end this off here. I'll hang out in the chat for a couple minutes here in case anybody who's watching live with me has any questions. If you're watching the recording of this later on and you have questions, feel free to email me, feel free to Teams me. Even if you're here live and you don't have a question now and you come up with one later on, contact me, email me, Teams me, get in touch with me. You know, I don't know you have a question unless you ask it. Right? So asking is super important. But I think that's where we'll wrap up for today. Again, if you have any questions, please let me know. Thank you for watching, and we'll see you next time.